Hello, and welcome to the lesson on areas of triangles and quadrilaterals. Hopefully a lot of this is review for you, and we can go through it pretty quickly. There's been some requests for music and other special effects, but I'm afraid I just don't know how to do that, so you're going to have to just deal with what we have here, and hopefully you can get through this pretty quickly. All right, so we're going to start out. We have area of a square on this page. This should be review for you, so you can get that down in your notes if you need it. Area congruence postulate makes sense. If the polygons are the same shape, same size, then they have the same area. And area addition postulate, which this is kind of just common sense. It just says the area of a region is the sum of the areas of its non-overlapping parts. So if I have some kind of shape here, and it can be whatever we want, and let's say it looks like that, so an irregular shape, I can put in a kind of a fake divider line and just add the two areas together. So I have A1 and A2. So as long as the parts aren't overlapping, you can just add the sum of the areas. Okay, area of a rectangle, base times height. Area of a parallelogram, base times height again. But what you need to make sure that you notice is where this height is. So it's an inside perpendicular height from one of the vertices. And the base is going to be the side that the height is meeting at a right angle. So make sure on your diagrams that you're finding the right height. Here we go from this vertex to this base. And so we could use this side as the base, or we could use this side as a base. Remember, those are equal values. So make sure you have the right height. Never use both sides as base times height. It's not the side of the parallelogram, it's how tall it is. Okay, area of a triangle. Again, you have to find the height. You don't use the side. We're used to that on a triangle. So just make sure you find that perpendicular height. Trapezoid, this may be a new formula for you. We have to add the bases together, so that's the base 1 plus base 2. Then we take that times a half, and then times the height. Again, the inside height perpendicular to one of the bases. Doesn't matter which one, so as long as you have that perpendicular height in there, you're good. Okay. Area of a kite. This is a new formula for you, and because the kites are kind of an irregular shape, we don't have the base times height idea, so we have diagonal 1 and diagonal 2. So the length of these two inside lines, so here and here. And we'll do an example of that one. Area of a rhombus. Now a rhombus is also a parallelogram, so we could still use the area equals base times height if that's the information that we have. Or if we don't have that information, we can use the 1/2 times D1 times D2. So diagonals again. So this one just depends on what information you are given. All right, so find the area. We first want to kind of analyze it, see what kind of shape we have. We notice the diagonals don't bisect each other. They do bisect one, so this is a kite. They meet at a right angle. So our area is going to be 1/2 times D1 times D2. So I have 1/2 times diagonal 1 is 16 plus 8, and diagonal 2 is 8 plus 8. So I'm going to take 1/2 times 24 times 16, and let's just make this easy. Let's take the 1/2 times 24, and we'll get 12. Actually, let's take 1/2 times 16 and get 8. So we have to take 8 times 24. And when I take 8 times 24, I'm going to get 192 units squared. All right, find the area again. This time we have a parallelogram. We'll put these markings on there so you know what we have. Okay, and so our formula is area equals base times height. Now we know that we have to find the perpendicular height. So that could be a line here. Sorry about that not being too straight. Or you can see out here I've drawn a perpendicular line. This could be our height as well. We know this side is 5, but we don't know this height. So what we need to do is find it. Okay, so we're going to use, since this is a right triangle, we're going to use the Pythagorean theorem. So I have 3 squared plus h squared equals 5 squared. 9 plus h squared equals 25. So h squared equals 16 and h equals 4. Okay, so we're going to go back up to our shape. H is 4. So now I can take one area is base times height. So my base is 12 and the height is 4. So this is 48 units squared. And the last one we have that we're going to do as an example is a combination of two shapes. You can see we have an irregular shape here, so we can't use a straight up formula to figure it out. So we're going to divide this into two pieces. If I look at it this way, I'm going to look at this shape first. Whoops. There we go. And this is area 1. And the second shape down here, area 2, is just a rectangle. So that's easy enough to figure out. So we divide it into its two parts, and we're going to calculate those separately. So let's start with A1. We have a trapezoid. So we have 1/2 times base 1 plus base 2 times height. So 1/2, the base 1 is 10, base 2 is 16, and our height is 3. So I have 1/2 times 26 times 3. 1/2 times 26 is 13. Take that times 3 and I get 39. So that's area 1. Area 2 is just a rectangle, so I just have base times height. I have 16 times 8. And when I take 16 times 8, I get 128. So now my total area is A1 plus A2, which is 39 plus 128, which is 167 units squared. Okay, and last, I want you to work this problem at home on your own. We've got 8 congruent rectangles. If the area of the entire blue figure is 120 square units, I want you to find the perimeter of the large rectangle. So remember, perimeter is if we were going to build a fence around it, how much fence would we need? So you're going to need 2 variables, which means you're going to need 2 different equations to relate those variables. And then you're going to have to solve them together. So go ahead and give that a shot. Think of it as kind of a bonus question. I don't know about Mr. Hudson, but I would offer some bonus points if you could get this figured out and show me how you worked it. Thanks. And hopefully this video was a little more entertaining for some of you, even though no music was involved.